Let's begin. Today's November 24th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 3, 9, 12, 16, 19, and 22. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our middle digit, the square digit, and compares it to the number 3. Should the value of square be less than 3? Should it be equal to 3? Or should the value of square be greater than 3? Criteria card B takes a look at our 3-digit solution, and the Turing Machine will let us know how many 3s there are. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 or 3. Criteria card C will take a look at our first and last digits, the triangle and circle, and compare them. Should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D again takes a look at our 3-digit solution, except this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F. Again, we'll take a look at our 3 digits, from triangle to square to circle, and the Turing Machine will let us know a little bit about the ordering of the digits. Should the digits appear in an ascending order, meaning that they're increasing, as in the example 135, should the 3-digit solution appear in a descending order, meaning that they're decreasing, as in the example 421, or should the 3-digit solution have no order? Now let's take a look at the given example of 231. Notice that it goes from 2 to 3, it increases, but then it goes from 3 to 1, decreasing. Of course, you could also have a 3-digit solution that decreases and then increases, but ultimately it's that shift from one direction to the other that is a way to define a 3-digit code as having no order. We've also seen in previous puzzles where if you have consecutive equal digits, digits that are equal, that are next to each other, that also exhibit that no order characteristic. For example, let's take a look at this example above of 331. So when you go from 3 to 3, it neither increases nor decreases. That's what I mean by consecutive equal digits having no order. There's no change. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my choice of 314. Notice that I do have 2 odds to a single even. Since the Turing Machine does not agree with that, it's in fact telling us that there should be more even than odds. So let's go ahead and type that up in our notes in section D. And we'll state that there should be more even than odds. So of course this means that you have at a minimum 2 evens, and that 3rd digit could be an even or it could be odd. So we're looking at potential solutions that are 2 evens and an odd, or an all even solution. So that would mean that criteria card B, the fact that it's querying how many 3s there are, since we have at most 1 odd, it's either there or not. But if it doesn't appear, that doesn't necessarily mean that they are, 1 or 5. It could still be an all even solution. Let's see, what else? Let's go ahead and test criteria card E. So of course, if you have two evens, the potential is that maybe the first two digits add up to 6. Obviously, I don't have a sum of 6, but let's go ahead and still test it all the same. So let's test criteria card E. Okay, yeah, so it does not approve of my choice in triangle and square. I did pick a 3 for triangle and a 1 for square. So 3 plus 1 is 4. 4 is less than 6, but the Turing Machine does not agree with that. So yeah, so either the sum of the first two digits should be equal to 6 or greater than 6. So let's go ahead and type that up in our notes for section E, and we'll state that triangle plus square should be either equal to 6 or be greater than 6. And so at this point, I don't think we can cross out anything. Is that right? Triangle plus square. Yeah, I suppose you could still have something like 1, 5. Well, you can't have 1, 5. That would be two odds. Well, wow, that does bring up a good point. You can't have two odds. So can you have 1? It would seem not. Since we have a majority of evens, if you pick a 1, nothing less than 5 would give us a sum that's equal or greater. Okay, so yeah, I think we can cross out 1 in triangle as well as 1 in square. Okay. Yeah, so yeah, 1 plus 4 is 5, yeah. So 2, yeah, 2's okay. Obviously it's even, but you could add it to a 4 or a 5. The only thing you couldn't add it to is a 3. And that's if you had a 2. We don't know that yet. But at least we eliminated those two possibilities. Okay, what else? What can we test? I did pick a 1 for square. Obviously that's incorrect. So it could be either less than or equal or even greater. I think for that fact, let's go ahead and test criteria card C. Okay, so it also does not approve of my choice for triangle and circle. Notice that I did pick 3 for triangle and a 4 for circle, where of course 3 is less than 4, but the Turing Machine does not agree with that. So either triangle should be equal to circle or be greater than circle. So let's go ahead and type that up in our notes for section C. And again, we'll say that triangle should be either equal to or greater than circle. So let's see, what can we say about that? So remember, we are looking for at least a 2 even solution, potentially 3 even. What can we say about this? So if circle, well, yeah, I guess circle could be 1 because it could be less than all of these values. What about 5? Well, can circle be 5? Well, there's nothing bigger for a triangle to be if circle were 5. So it would fail the greater than, and it can't be equal to it either, since you can't have two odds. So yeah, I think we can cross out the 5 in circle. It's too big for triangle to be anything bigger. And of course, you can't have it be equal to triangle? Now, triangle could be 5. There's nothing wrong with that. And I think everything else is okay. Yeah, circle could be a 1. It doesn't have to equal triangle, but it would be less than. Let's see, what about 4 for circle? I guess you could I guess you could have circle be 4, because triangle could be 5. So I think that's okay. Okay, well, I don't think we can cross out anything else. So let's go ahead and just conclude that, yeah, we've already completed our 3 Turing tests for this round. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing that middle digit, the square digit, to the number 3. We also did not establish how many 3s there could be. Obviously at this point, it's either there or not, but it doesn't mean that it has to be a 1 or a 5. It could still be an all-even solution. We still have criteria card C a little bit outstanding. It could be equal. If they are, that could be our 2 evens. What else? And we still don't know quite the sum. The only way it could be a sum of 6 is if we have a 2 and a 4. And then we also have criteria card F, the ordering, establishing the ordering of our 3-digit solution. So I do recall that I believe we can deduce that the solution should be have no order because of the interaction between criteria card C and our criteria card F. And the argument goes as follows. If you presume that the solution should be in an ascending order, meaning that they're increasing, then you would absolutely know that triangle should be less than circle. And this precludes, our beginning of the puzzle, where we've already established certain facts thus far. But even before that, if you know the solution would be ascending, then you would know that triangle would be less than circle, thus making criteria card C irrelevant. And similarly, if you were to presume that the solution would be descending, meaning it's decreasing, then you would know that triangle should be bigger than circle, again making criteria card C irrelevant. So presuming either increasing or decreasing would let us know something about the ordering or the comparison of triangle and circle, which again, all cards have a purpose. So that means that I think it's safe to presume or to deduce that the solution should have no order. Okay, so we are looking at a solution that has no order, that has a minimum of 2 evens. And so let's see, what if square were 3? Since that is a possibility. If square were 3, then we would know that the sum could not be equal to 6, because that would mean that triangle would have to be an even, and therefore it would have to be a sum greater than 6. So what are the possibilities? Well, it would be, again, if it's 3, it would have to be something like 4, 3, 4 because of no ordering. It couldn't be 4, 3, 2. And it certainly couldn't be 5, 3 because you can't have 2 odds. So that would be it. You would have only one possibility if the sum were, if square were 3, it would force it to be 4, 3, 4. Now there's nothing that says you can't have duplicate evens. You do have to have at least 2 evens. What else? So if the sum, and that's only if the sum is greater than, and technically if square were 3, that is. Okay. You could have, let's talk about sums of 6s. So either it would be 2, 4, or 4, 2. And of course, square would let us know which one it would be. So if it were, say, square is 2, it would be 4, 2. And, well, at this point, it better be a 3 because there's, we've already eliminated, well, I guess it could be 4, 2, 4 as well. It could be 4, 2, 4. Yeah, so you'd be distinguishing between 3 and 4, and you could have an all-even solution. That's still very possible. What about if square were 4? Obviously greater than 3, but we know the sum is 6, so it would be 2, 4. And then you'd have to be picking between 1, 2, and 3. Well, I don't think that can happen because, well, I guess, well, the only possibility is it would have to be a 3 because there's really no way to pick between 1 and 2 for circle. So you are looking at something that's 2, 4, 3. It would almost force 3 to be there. Well, that was the same case. It was 4, 2. It would have to, well, no, not necessarily. Again, it could say, no, there are no 3s, so you pick a 4. So 2, 4. Yeah, in this case, it'd be 2, 4, 3, or 4, 2, 3, or 4. So yeah, that 3 is quite important. And there just seems to be too many possibilities where the sum is going to be greater than 6. So yeah, let's go ahead and say, I'm going to go with 4, 2, 3. So let's see what happens. 4, 2, 3. And just to go over it, is triangle equal or greater than circle? Yeah, triangle is bigger than circle. 4 is greater than 3. There are more evens. We're proposing that the sum is 6. Yeah, that's still valid. And that has no order. Okay, so let's give that a try. Well, I think the whole purpose of this proposal was to confirm the sum is 6. So let's go ahead and test criteria card E again. Okay, yeah, so the sum is absolutely equal to 6. So that means we can definitely cross out numbers. So obviously it can't be a 3 because you would have to add it to another 3. And again, to have a sum of 6, you'd have to have 2 of the same kind. You can't have 2 odds. So essentially, yeah, we're crossing out all of the odds in square and, in triangle and square. Okay. So crossing that out. Can we cross out anything in circle? No, well, let's see. Yeah, I think we can cross out. Now that we've established that triangle is, the largest is 4, well, no, I guess you could technically still have a 4 for circle. It can be equal. Yeah, I think that's valid. I don't think you can actually cross out anything. Okay. Well, let's actually test. We're down to either A or B. Boy, I sure hope we don't have to test C again. Let's go ahead. Yeah, in order to figure out what the sum is, let's see. Well, again, 2, 4. Yeah, I guess it could be 2, 4, 2. If they're equal, well, if they're equal, would you really need to compare or to find out how many 3s? I don't know, now we're getting into the realm of pre-game and being in the middle of a game. I guess at this point, let's go ahead and test criteria card A, because I don't think there's a way to deduce that. Okay, so I did pick a 2 for square. 2 is less than 3, and the Turing Machine approves. So let's go ahead and type that up. So we'll say that in our notes for A, we'll say that square should be less than 3. Okay, and of course that establishes that square should be the 2. So let's go ahead and cross out the 4 in square, and we will cross out the 2 in triangle in order to establish that sum of 6. Okay, so we're looking at 4, 2. Now, we can cross out the 1 in circle, because that would be a descending solution. We sort of deduced at the top of this round that it's not likely to have a descending solution. So let's go ahead and cross out the 1. And so now we're down to 4, 2, 2. That's less. 4, 2, 3, and 4, 2, 4. So very interesting. I'm almost leaning that, yeah, it should be equal to 3. Let's see. So 4, 2, 2, that would be triangle is greater. That's correct. 4, 2, 3, that's also greater. And then 4, 2, 4 is equal. Well, quite the dilemma. What to test? I really don't want to go to a third round. So is there a way, if I test one of them, how would I pick? Well, I think if I were... So 422 and 423 have both, they are less than. But then I would have to test criteria card B to establish, well, should there be a 3 or shouldn't there? If I test criteria card B and it lets me know, yes, there's a 3, okay, fantastic, that's my answer. If not, then I would definitely have to test criteria card C. Now, is there a way to know for sure? Is there a way to deduce the second part of criteria card C? They're both less, not equal. You know, I'm betting on 4, 2, 3. So let me go ahead and test criteria card B to establish that, yes, there is a 3. So I'm hoping for a check mark. No check mark. There is no 3-digit. Oh, wow. Okay, well, let's type that up. So we'll say that the solution has no 3-digit. Quite unfortunate. So let's go ahead and cross out the 3 in circle. And so it comes down to either being that they are equal, triangle and circle, or less than. Well, I guess it doesn't really matter. It is an all-even solution. I'm just going to say 4, 2, 2 in the third round. Quick third round proposal. 4, 2, 2. And so let's test criteria card C to establish if it's less than or equal to. Okay, so yes, it is true that 4, 2, 2 is correct. It should be true that triangle is greater than. So it can't be equal. So that establishes that our solution should be 4, 2, 2. So let's go ahead and cross out the 4 And so let's type it up, 422. And another puzzle with quite the twist, where we have 3 even digits. Well, let's go review before we verify. So is that middle digit less than 3? Sure, it's a 2. There are no 3s, that's correct. Triangle, the first digit should be greater than the last. Yeah, 4 is greater than 2. There are more even than odds, they're all even. The sum of the first 2 is 6, and we deduce no order. As I mentioned at the very top of the video, consecutive equal digits, as in 2, 2, it did not have to be the first 2, it could be the last 2 that are consecutive. There is no change between 2 and 2. Obviously it's not a decreasing solution. So yeah, that also falls under the definition that I lined out at the top of the video. 422 has no solution. Well, let's go verify. That, again, 422 is our solution. 422. Fantastic. Okay. Well, how do we do versus a Turing machine? Well, it is a 6 criteria card puzzle, and we did 7 tests over 3 rounds. Well, we'll see how we did. We did C, D, E in the first round, all incorrect. We tested A and B, which we had not done so, and we retested E, with B being the only incorrect, and then we retested C. Okay, so let's type that up so hopefully I'll remember all of the details. So C, D, E, and then A, B, E. So C, D, E were all incorrect. A, B, E, I believe A was correct, B was incorrect, and E we did get correct. And in the third round we retested C and got it correct. Okay, so we tied, which is a win. Okay, quite pleased with that. Of course, I always ask what sort of efficiencies could I have made? Could I maybe tested it a different order of criteria cards? Of course, it also comes down to maybe the proposals themselves, but not sure. Obviously, we got very fortunate that we were able to deduce in no order. That sort of did help us get that win, so that we tied. We did not have to test that, but we did have to retest C and E. Could I have done it without doing that? Not sure. But how about you? How did you solve it? What criteria cards did you pick? And did you observe something interesting that you'd like to share? Please add those to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.